We are going to continue our study of systems, but now we're going to have some special types of systems. Okay? Sometimes there is no solution, okay, or it's called inconsistent. So when a linear system has no solution, we say that the system is inconsistent. Okay, how can this be? How could there be no solution? Okay, let me show you a couple ways. Maybe you're solving it algebraically. Okay, so here's what it's going to look like. I'm going to try to do elimination on this system. I'm going to try to maybe I'll try to make the x's eliminate. So I'm going to multiply the entire top equation by a negative. Okay, so my system is now negative 3x minus 2y equals negative 2. Don't forget to give the negative distributed to all three terms. The second equation I just left alone, and now I'm ready for elimination. So the x's eliminate. I'm going to combine the y's. Oh my, negative 2y, positive 2y. Okay, when I add those together, those also eliminate. They add up to 0. That's weird. Okay, you have to keep going. Negative 2 plus 10, or you could say 10 minus 2 is 8. And now you have to ask yourself, is that true? Okay, no, it's not equal. You have to change that to a not equal. 0 does not equal 8. That's false. And so we say no solution. If you don't like writing that, there is a mathematical symbol for no solution. It looks like an O with a slash. Okay. Either way would be fine with me. That is the mathematical symbol for no solution. Okay, so if you get something that's false, then it's no solution. I'm going to write that note down here. Okay, if false, okay, then it's no solution. If it is not true, you say no solution. 0 does not equal 8. Okay, let's solve this system here by graphing. I'm going to show you what a graphing system looks like that has no solution. So my first line is in y equals mx plus b form. I'm going to start at the 1 for the b value. We're going to go down 3 over 2. Down 3, right 2. Down 3, right 2. Also going to go up 3, left 2. All right, this is a fair amount of points. I'm going to go ahead and graph the line with arrows, and that is the first line. Maybe I'll color code it here for you. Okay, I'm going to graph the second line now. The second line has a y-intercept of positive 5. Okay, so this one's starting up a little higher. The slope is negative 3 over 2, so I'll go down 3, right 2. Down 3, right 2. Okay, let's keep going. I'm trying to see where they intersect. Down 3, right 2. When are these lines going to touch? It's kind of weird. Let me draw the line here. These lines, those lines are never going to touch. Okay, these lines have the same slopes. If they have the same slopes, that means that the lines are parallel. And parallel lines, they never touch. So you could graph all day long, but they're never going to intersect. Okay, and so here, if I look at a graph like this, I would say no solution. Okay, so I cannot find the point where they touch because they don't touch. So algebraically, when you're doing it mathematically, if you get numbers that are false, you say no solution. If you do it graphically and they don't touch, you say no solution. Okay, that's the first special type of system. The second one, okay, this one's a little different. It's called dependent system. Dependent system has infinitely many solutions. What? When a linear system has infinitely many solutions, how can I have many solutions? That's weird. Then we call the system dependent. Okay, so you have to know infinitely many and you have to know dependent. There is a mathematical symbol for this too, and sometimes people say infinitely many. Infinitely many solutions. That would be a shorter way of saying that. Okay, let me show you what this looks like. I have a system here. I'm going to use substitution. So I'm going to take, this variable is isolated. Let's take this quantity right here. And we'll substitute it in for that y right there. So the top equation is x minus 2. Okay, and what am I replacing y with? That whole quantity, 1/2 x plus 2. That was the y. Then we have the equal sign and the -4. All right, let's do our algebra. -2 times 1/2. That's going to be -1x. A negative times a positive is -4 equals -4. Okay, 1x minus 1x right here, that cancels out. That cancels out, right? Now we have -4 equals -4. Okay, you have to keep going till you get to the end. And is that true? A -4 equals a -4? That is true. When you get something that's true, we say infinitely many solutions. You're telling me any solution in the world would work? Well, not any one, but that there are infinitely many of them. There's lots and lots of solutions. Okay, if I show you graphically what happens, you'll see all of the solutions. Let's go over here. Okay, I'm going to graph line number 1. 1/2 x plus 2. So I'll start at the 2. I'm going to go up 1 over 2. Up 1 over 2. Down 1, left 2. Down 1, left 2. And in the first line, I'll color code it for you, is purple. Okay, so the first line is purple. I'm going to graph line number 2 with my red marker. So I'm going to color code this for you. This line right here is going to be the red line. I'm going to start at +2. Same place as the other line. I'm going to go up 1 over 2. Wow, I'm doing the same thing as the last line. Down 1, left 2. Where should I draw this line? I guess I'll draw the red line right on top of the purple line. That's weird. It's right on top? The reason it's on top is these two equations, okay, equations are exactly the same. Exactly the same. The equations are the same. So of course the graph is the same. So what points do they have in common? Does this point belong to the purple line and the red line? Yes, they have an intersection point right there. And they touch right there. And they touch right there. And they touch right there. All of their points. All points are shared. Okay? So there's not like every point in the world, but there's infinitely many points that they both have in common. Okay, so we say infinitely many solutions. If you're doing it graphically, the line is right on top of it, and it's the same line. If you're doing it algebraically, you get something that's true. Okay, let's turn the page. Consistent or one solution, this is kind of what we've been doing all along. Okay, a consistent system has one solution. Okay, so I'm just going to say this is the old stuff. This is the old stuff. That's what we've been studying this whole time. A linear system has only one solution. We say that it is dependent. If we know that a system has only one solution, okay, we need to identify the point, the x value and the y value. So this is like the old stuff. Two lines intersect, tell me the one point, okay? And that's called consistent. All right, number 3. Solve using substitution, okay? So it says substitution. I'm going to follow directions. I'm going to take this quantity and replace it with the y. All right, here I go. X plus 2 times y. Y is 3x plus 2, and that equals 11. Okay, now let's do our algebra. We'll distribute x plus, how many x's is this? 6x plus 4 equals 11. Are we going to get something that's true or false or get an answer? I don't know. X plus 6x, 7x plus 4 equals 11. Keep going. Subtract the 4 from both sides. 7x equals 7. I'm getting a solution. I'm getting half of it. X equals 1. Okay, so I've got half of the point. We need to find the other value, the y value. I'm going to plug 1. Let's put 1 in right there into that x spot. That seems like a good place. Y equals 3 times the 1 plus 2. So my y value is 5. I got one solution. I got one solution, and there it is. Okay. Number 2. Maybe you want to solve this system with graphing. Okay. I rearranged this equation here for you already. It's the same system, but we could solve it by graphing if you don't like substitution or even elimination. Let's go ahead and graph the first line right here. Line number 1 has a y-intercept of 2. We would go up 1, 2, 3 over 1. Down 1, 2, 3 over left 1. Down 3, left 1. Okay, so the first line seems pretty easy to graph. I'm not sure if the second equation is going to be so much fun to graph. I probably would solve this system with substitution and algebra. I probably wouldn't choose graphing when I saw numbers like this. Okay, I'll show you what it is. The y-intercept is 5.5. You go down 1 full box, you're in the middle. Okay, over 2. Down 1 full box, over 2. Does it look like it's, well, it definitely looks like it has 1 point. Does it look like it's the point 1, 5? Yes, yes, it's the same solution. 1, 5. So does it matter which way you do these? No. If it looks too icky to graph, then maybe we should do algebra. Okay, here are some graphs. All we have to do is tell whether it has one solution, no solution, or many. Okay, one solution means it has a point. Infinitely many, okay, means that it's, I'm sorry, no solution will write this symbol. Infinitely many will write the infinity symbol. Okay, and one solution will just say the point. I see parallel lines never touching, so this one's going to be no solution. No solution. Or if you like, you can write no solution with the math symbol. I see two lines here. They are intersecting just one time. Yes, that has a solution. Okay, it has one solution, and go ahead and tell what it is. The only solution that they have is the point 4, 3. Okay, so if it has one solution, just tell me what it is. Okay, without graphing, tell us how many solutions there are without graphing. Okay, so this time they want us to do algebra. Let's zoom in here. We're going to do algebra to figure out how many solutions they have. Okay, so let's see. Is it set up for elimination? Yeah, kind of. I could do elimination or substitution, but I can't do graphing. I'm going to do elimination since they're all lined up. I'm going to multiply this top equation by the number 2. Okay, so the system is now 10x plus, distribute there, 2y equals -4. And then the bottom equation is -10x minus 2. I just leave the bottom equation the way it is. Okay, now we're all set up and ready to go for elimination. The x's are canceling out. The y's add up. Oh, those cancel out too. If everything cancels out, that makes the number 0. There's 0 x's left and 0 y's. -4 and a +4. Oh, look at that. Does 0 equal 0? Yes or no? It does. Okay, that's true. That does work. So, is there one solution, no solution, or infinitely many? Well, there's not one solution because I didn't get x equals. When it's true, we're going to say infinitely many solutions because it's true. All right, let's do number 6. Since it's all lined up like this, I think I'm going to choose elimination again. I'm going to multiply the top equation by a negative. Okay, so now the top equation, everybody has to get changed to the opposite. -6x, -2y, -3. The bottom equation, I'm just going to leave the way it was. Okay, are you ready for elimination? The x's are canceling, and the y's are also canceling. So what number is that? 0. Now I can't really answer until we keep going with our calculation. -3 and -5 make -8. So I didn't get any x equals or y equals, so I don't have one solution. It definitely canceled out. You ask yourself, is this true or is this false? That's false. Okay, since that's false, we're going to say no solution. Or if you like that symbol, remember what it was? It was that 0 with the thing. Okay, we could have just circled these here. I could have just circled no solution here, and I could have just circled infinitely many solutions here. All right, we got one last example. Okay, stay with me here. Should I solve this with elimination or substitution? Maybe I'll do substitution. Maybe we'll just move the 2x to the other side. Y equals 2x plus 3. And then I could substitute this into the y place. Could you rearrange and do elimination? Yeah, you bet. You bet. If I rearrange the top equation, put x's first and then the y's, you might have to do a little bit of work. Okay, so this is the top equation rearranged. It's not quite eliminating, but you certainly could get it to eliminate. Okay, so either way you want to do this problem is fine with me. If we continue over here with substitution, let's plug that in. 2x plus 3 equals 2. X plus 2x, that makes 3 x's. Okay, so I'm noticing here I still have an opportunity to get a solution. Okay, the only time you say these weird things is when all your variables disappear. Okay, but if you still have a variable, keep doing your algebra. I'm going to subtract 3. 3x equals -1, and I'm going to divide both sides by 3. So it looks like I'm finding a solution. I'm finding one solution here. I've got half of it right now, okay, and I would just have to go for half more. Do we need to keep going, or can you tell me if there's one, no, or infinitely many? Yeah, there's just going to be one solution. Okay, for people that want to find the y, you could go find it, and then you'll know what the y value is. But I know there's just one point in this case. Okay, that is everything from this video. I can't wait to see you tomorrow. Take care.